So, what's up, guys, and welcome back once again. So, I found quite a nice article from Voyage AI. I think it was by MongoDB about RAG systems and embedding models. So, I think if you have been building RAG systems, I think this one is one for you. I think it's an interesting model that I have come to realize. So this is the Voyage-Context-3. I think this is an article that was published on July 23rd, 2025. So I think this is quite a nice model that has come into fruition. I think maybe I'll take time to take you through and see how we can actually apply these embedding models. So this embedding model. So this is Voyage Context-3. So actually, Voyage actually has nice models. I've been actually building a RAG system for the legal domain, or in the legal that can be applied within law firms, and I've been researching quite a lot when I was considering about the best embedding models to use. So initially, my research, initially I tried to go through, I think it's the MTEB leaders board. I might be missing the word, but I think it's the MTEB leaders board from Hugging Face. So I think that was my first landing spot for trying to find the best model. So I tried a couple of those models. Some were working okay, some were not. I was not getting the best retrieval when I was doing the retrieval. I was not actually getting the best quality in terms of retrieval. So during that search, then I think I happened to land on Voyage. I think Voyage has a number of embedding models. So I think we just Voyage, just do a quick search, embedding. I think Voyage has quite a number of embedding models that I've tried to implement, to use them while building these RAG models. And I think with the Voyage, I think the retrieval accuracy improved. So when you layer on that, I think the re-ranking now mechanism, I think you tend to get a better responses, because you are on top of that, you are also layering the LLM layer. So I think I've tried a couple of models, embedding models with Voyage, and I think this one is the new one, Voyage-Context-3. But I've tried one, I think, with the Voyage Law, this one, because I'm actually working within the legal domain, so I think I preferred using this. But I've tried the other ones for other practice areas, and I think Voyage really has nice models, nice embedding models. But for this one, let's try to go through the Voyage-Context-3 and see how best we can actually use this model. So this is just some abstract. As you know, articles normally do have an abstract, so you have to have an abstract to try and explain this. So with this abstract, I think so I've tried to highlight some of the best information that we can actually get from this, and this one we can use. I'll try this to try and elaborate more on what this model can actually help us with. So the first one, we're excited to introduce for Context-3. So this is actually a new model, and with this model, it's a new model where contextualized chunk embedding model, where chunk embedding encodes not only the chunk on context, but also captures the contextual information from the full document. So with this model, actually what they are trying to say with this one is that when you are building these RAG models, I think most of you can understand the the problem that comes with chunking, trying to find the best chunking strategy. So with the Voyage-Context-3, what it enables us to actually achieve is that we're able to capture I'll say we're able to capture the idea within, or the information within a chunk with respect to the entire full document. So I think that's what the Voyage-Context-3 actually comes with, which I think it's quite nice. So another thing is about the drop-in replacement. So I think it supports numerous embedding dimensions. So with this one, actually it becomes easy. So you can just do a plug and play within your RAG model, and you'll be good to go. And also compare these to other context agnostic models like the OpenAI one and the Cohere one. The Cohere V4, you can see that based on what we'll see in terms of the metrics that they use to rate this model, you see that actually tends to perform quite better. So this is just some of the metrics but we'll cover them later. So the chunking challenge in RAG, actually this is one of the main things about RAG systems, the chunking strategy that you're going to implement in your model. Having a better chunking strategy ensures that you'll actually have a better model. The retrieval accuracy will be better, and the responses that you're getting will be better. So the chunking strategy is quite important. And so when you are actually with this one, so we have the focus, detail, and the global context chunking strategy. So when you are trying to break your document down, so we break down into small chunks. Small chunks, you can say these to be paragraphs. So consider a document. So I have a document. So for example, this is a textbook. So I have this textbook. This textbook contains, let's say, chapters, pages. These pages, chapters. Chapters have paragraphs. Paragraphs have sentences, and sentences have words. Okay. So what we need to understand with the chunking, because we cannot just take the entire textbook and do the embedding on that. What we might be missing, or we might be missing some information when we are actually doing our retrieval. So what we do is to try and break those text into chunks. For layman's language, you can say paragraphs. So you can break those into context-aware context paragraphs. Paragraphs that actually do bear some meaning. Then once you are able to chunk those into those paragraphs, then you can do the embeddings on each and every paragraph. So initially, the chunking strategy was actually done, or it was driven by the model limited context window. So this one actually tells you what the number of tokens that you will need within that chunk. So with I think different models did have, or different models do have that limit in terms of the context window that you can use. But originally that was what was intended. Okay. But more importantly, it allows with the chunking, it allows the embedding to, with now using the paragraph version, we're able to do the embeddings so that those chunks are able to contain fine-grained information about the respective passage. So that's why we do the chunking strategy. However, sometimes this focus can be. However, when you're doing the paragraph embeddings, I think that's what we're getting from here, is that when we're doing the breaking the text into paragraphs, we tend to lose the information that the entire corpus or the document actually bears. So that's the problem with when you are actually doing the paragraph embedding. So with the embedding that requires the entire text, becomes a problem because you cannot pass the entire document you cannot pass the entire document for the embedding process because you tend to lose a lot of information with that. So, a solution for that was the paragraph chunking, and you're going to do that, you tend to miss the entire picture that the entire text actually bears. So actually, they are actually offering an example. So for instance, if a 50-page legal document is vectorized into a single embedding, detailed information, such as, for example, this sentence. So let's say we want to look for this. We want to look for information around this sentence. For example, all data transmissions between client and service providers infrastructure shall utilize AES 256 encryption in the GCM mode. Okay, so if you're just going to pass through this 50-page legal document, then we tend to be missing fine-grained information like this one. Okay, so it will be buried or lost within the aggregate. But if we decide to go with the chunking with paragraphs and vectorize that, then we'll see that by chunking the document into paragraphs and vectorizing each one separately, because split into paragraphs, then you vectorize each independently, then the resulting embeddings will actually capture our sentence properly, especially if you want to be keen on the type of encryption we want to use. So this is the AES 256 encryption. So the paragraph chunking will actually capture that very well. Okay. However, such paragraphs may not contain the global context. So that is what those paragraphs that will tend to miss the global context that the entire corpus or the entire document actually has. So the ideal scenario, or I'll say, what do we expect, or what do we want with this with the chunking strategy that we're going to use? So the ideal scenario is that I want to focus both on the details and the global context. So if you find a model that can actually capture the minute details, which are very important, especially if you're working with when you're building RAG models for health, let's say law, where these simple tidbits of information are very important. So if you're working with that, then I think we need to find a way so that we're able to focus on the small, minute details, which are very important, and also we are not throwing away the global context, so the information that the entire corpus of the document has. So we need to find a model that actually works with this and without the trade-offs. So common workarounds that we usually do was to actually do the chunk overlap. I think that one is very clear. Then the context summary, so you take those paragraphs, try to do a summary on that. Then the metadata augmentation. Mostly I've been using the metadata augmentation, but that process sometimes is very tedious. And you can see that we are trying to introduce extra steps into an already complex AI application pipeline. So you can see these processes, sometimes they are very tedious. Sometimes it requires manual. Sometimes when you are doing the cross-checking and things to do with that, it tends to be a lot of maybe manual work if it's not if most of that work is not well automated. So you can see there's some type of trade-off, but now you can see with the Voyage-Context-3 how it tends to help us try to navigate this type of problem. Now we introduced the contextualized chunk embedding procedure. So with the contextualized chunk embedding, this one actually comes in so that we're able to capture both the focus details and the global context within those chunks. So we are not running away from the chunks. Okay, we're not running away from the chunks. So, but what we are embedding within those chunks is the global information. Okay, within that entire text that we are trying to embed. Okay, so the model processes the entire document. So if you have that 50-page document, it processes that entire document within a single pass and generates distinct embeddings for each chunk. Okay, So after that, now each vector encodes only specific information within its chunk, but also the coarse-grained detail level context, enabling a rich and more semantic aware retrieval. So once we do the single pass and generate the distinct embeddings, again I said you're not running away from the chunks. Then the chunks will also bear some global information, so that we're able to capture both the global information and the information that is within those chunks. So the key here we can see is that the neural network actually sees the chunks at the same time and decides intelligently what global information from other chunks should be actually injected into the individual chunks embedding. So you have the individual chunks, and then when you're doing the embeddings, the neural networks tries to intelligently find out what other information from other chunks that this specific chunk that we are actually doing the chunking process should actually bear. So that you can see we are not only making consideration of the chunk that we have actually decided maybe it contains some specific information. We're also adding some other information from various chunks, so that at least we have a holistic chunk that whenever we pull this, we're able to create a better context around it. So this is an image that tries to explain that. So with that one, we're able to realize some benefits. So one of that is about the full document automatic context aware. So you can see, because you're able to embed the global information of that text within those chunks. So we are able to actually have a context-aware chunks. So we're able to capture the full context of the document without actually requiring the user to manually or explicitly provide the contextual information, which is very important and eases the process of us actually building these models. Because garbage in, garbage out. The better refined your chunks, the better retrieval and the better response you're actually going to get. Then the seamless drop-in replacement, I think this one I've actually talked about. This is where the Voyage-Context-3 can actually output embeddings of different dimensions. So it's from sort of a plug and play. You don't need to actually redo the entire RAG model. Then another thing is that it's less sensitive to chunking strategy. With the RAG models, actually, we need to come up with a better chunking strategy that captures contextual information within those chunks. Okay, so with the Voyage-Context-3, it comes in handy because the contextualized chunk embeddings are shown to reduce the system sensitivity to these strategies, because the model intelligently supplements overly short chunks with global context. So when you're doing those chunks, sometimes you might find chunks are having a varied number sizes or tokens. So we're able to, those short chunks, we're able to supply or supplement those with the global context to make them feature rich. Then in terms of analysis, you can see the contextualized chunk embeddings actually outperform the manual or LLM-based contextualization. I think the LLM-based contextualization, I think it's mostly used so that at least you try to speed up the process of chunking. So if I have a text, then I can just use the large language models so that they're able to provide some context within those chunks. And I can use that context to come up with the metadata, and that metadata is the one that I'll be attaching to those chunks. But you can see with the Voyage-Context-3, it will try to help us try to avoid the LLM-based contextualization, sometimes, which is also a tedious process. Now for the evaluation details, you can here you're talking about the chunk level and the document level retrievals. So for every given query, we need to have for a given query, we need to pull the chunks. So that would be the chunk level retrievals. So what chunks are in high correlation with the user query? Okay. So another thing that we need to also understand is that the document level retrieval. Again, we are retrieving these chunks from our vector store, but these chunks are from a particular document. Okay, so that now from what document are these chunks actually coming from? So I think that is what we are getting with this image here. You can see that the figure below illustrates both the retrieval level across chunks from n documents. So you have documents, from the documents you get your chunks. So the most relevant chunk, this is referred as the golden chunk, bolded with green and shown in green, and its corresponding parent document. So we're able to know this chunk, and actually because of the global context, we're able to understand from what parent document is this chunk actually coming from. So we have the data set. So we can, this is how the evaluation was done. The 93 domain-specific retrieval datasets spanning from 9 domains: the web, reviews, law, medical, long documents, the technical documentation, and all that. So I think you can read that. So this is how the evaluation process was actually done. They also use proprietary real-world datasets such as technical documentation and documents within the containing header and metadata. Okay, so after doing all that evaluation, then the models, in terms of the models, they evaluated the Voyage-Context-3, the one that we're talking about, in relation to text embedding 3 large from OpenAI. Then we have the Cohere, I think version 4, if I'm not wrong. Then the Gina embeddings, the Voyage 3, and the Voyage 3 large. Okay? So what are the results? So what are the results after doing this embedding? So in terms of results, we can first look at the domain-specific quality. So if we are going to apply Voyage-Context-3 within different domains, so where are we going to get some marginal improvements? So that's the thing that we're actually comparing here. So we can see actually Voyage-Context-3 performed well in different domains. When you're looking at the web, law, medical, long context, tech, code, finance, conversation, and multilingual, you can see for the first row, you can see except web, medical retrieval quality of, let's say, 70%. For the lower deck, you can see that retrieval is about 80% and above, which is quite impressive. Voyage-Context-3 also performs other models across all domains in document retrieval, as shown in the corresponding chart below. So on average, Voyage-Context-3 outperforms OpenAI, Cohere, Gina, and the contextual retrieval by 12, 5.6, 6.7, and 2% respectively. So you can see, okay, for the contextual retrieval, the margin is quite small, just to also tell us that the contextual retrieval is also a good way for maybe doing the chunking, so that we're able to understand how those chunks, if to try and find out the information within those the paragraphs. Okay. Now for the real-world datasets, again you can see that Voyage-Context-3 actually performed better when you are technical for the technical documents and also the in-house datasets. I think these datasets from Voyage. Chunking sensitivity, I think you have talked about this. We can see that Voyage-Context-3 is actually less sensitive to various variations in chunk size and delivers stronger performance with the smaller chunks. So it delivers stronger performance with smaller chunks, which is to be expected. The smaller the chunk, the better or the higher the retrieval accuracy. So that is an expectation. But for the Voyage-Context-3, what it adds, and what we have seen, is that it adds the element of the global context. So it adds to those small chunks and thereby increasing the retrieval accuracy. For the context metadata is again very important as of now. So comparing the Voyage 3 large with the metadata, with context metadata, and a Voyage 3 context with context metadata. So I'm just looking at the retrieval quality with and without the metadata. So Voyage 3 large with the context metadata, you can see how it performed. But Voyage 3 with context metadata, I think it's outranked Voyage 3 large with and without a metadata. So you can see that actually Voyage-Context-3 is, I think it's showing some good performance. And then for the Matryoshka, embedding and quantization, again, this is very important. I think this one is what we talked about, the plugin, the plugin, like Voyage-Context-3 actually works as a plugin. So it supports the 2048, 10, 24, 5, 12, and 256 dimensional embeddings. So that means that if you are working with another model that outputs these types of embeddings, you don't need to actually overhaul your entire system. You can just plug and play your Voyage-Context-3 and you'll be able to move forward. Okay. So actually, this is I'm seeing that this is actually a nice embedding model. I haven't yet actually practiced with it, but I'm thinking of actually doing some couple of practices with the Voyage-Context-3 to see how it actually performs. So I've been working with the legal RAG systems. So I've been trying to come up with one, and so the one that I've been using, I think, is the Voyage. Voyage Legal Law 2, but I'm seeing a better performance from Voyage 3 large, so context 3, sorry. So I think I'll try to embed it within the workflow and see how it will actually perform. Okay, so I think that's it from us today. So I'll be trying to come up with these articles, maybe for the RAG systems, agentic AI, and so on, so that you can see what developments that are being made in this field. As you know, this field actually has there's more information to actually ingest. Okay, if you are, I might be actually trying to actually experiment with the Voyage-Context-3, then you only to come to realize that there's another embedding model that is out there actually performing better. So we are living in a stage where information is quite where these models are actually being improved faster, and you might end up missing such type of info. So I'll keep you updated, and that's it from me. That's it from me today. I think see you next time. Bye bye.